So we have 5 and 7 left to finish on these notes, and I actually think you guys can start 5 without me. So why don't you take a second? Let's do 5. Don't forget, we want to figure out what our vertical asymptote are, our horizontal asymptote, our x-intercept, our y-intercept. And did we talk about holes yesterday?
Yeah.
Yes. We'll talk more about holes, but if there's holes, see if you can identify that. So see what you can do without me. I'll put my work up on the board and then we'll talk about it momentarily.
I got a question. Why'd you get one digit for HA instead of?
So HA is the one where you look at the exponents, and if they're the same, then you make a fraction of their coefficients. VA is when you look at the denominator and set the denominator equal to 0. Yeah.
It's not a big one. Oh,
If you set that denominator equal to 0, I get 5 times x minus 1 equals 0. And if I would divide by 5 first to get x minus 1, and that's 0, and then you add that 1 to both sides.
okay.
Yeah, Sophia.
Wait, I said I got 5 and -1.
So I would say that -1 canceled out a minute ago because it was on top and bottom, so that's why it becomes my whole.
Okay.
Good question. All right, everybody else check out my vertical asymptote, horizontal asymptote, x and y intercepts, and the whole.
How did you figure out the whole? Yeah.
Good, so the whole is that canceled factor, and so x plus 1 equals 0, so that's how I got that -1. And
It's
then
the one that you crossed out.
the one you crossed out. So like this becomes our whole, so I do x plus 1 equals 0, and so that's how I get that -1. And then in order to find my y value, you can plug that -1 in for your x. So I plug -1 in here, -1 minus 5, and then 5 times -1 minus 1. That gets me 3/5. Okay, now that I have all of these pieces of information, I'm gonna go graph my stuff. Are we okay with that? Are you ready to go graph? All right, let's go graph. Okay, so my asymptotes are 1 and 1/5. And 1/5 is just somewhere between 0 and 1. I'm not gonna mark you off because I'm like, you graphed 1/2. No, as long as you just graph between 0 and 1, you're fine. And then I'm gonna go graph my x-intercept is at 5. And my y-intercept is at 1. And my pole is at -1/3, which is right about there. And this one's actually nice because I've got enough like points in each quadrant that I need to have my C curve in. So I have enough, I just get close to my asymptote on both of them and go through my points that I have drawn there. As long as you hit all the points and you're in the right like spot of the graph, I don't really care what your curve looks like. It can be like way more extreme than mine is, as long as it's a little C curve in there. All right, any questions on this one? This is probably like the most common one that you'll see. This is one that we're really comfortable with. We did other weird ones, and we're about to do another weird one where we are doing one of the slant asymptotes. So number 7 is another one that's like number 6. So I can find vertical asymptote easily. I can find x and y intercepts really easily. That horizontal asymptote will, instead of being horizontal, it will be a slant. So we're gonna have to deal with that. Okay. So when you're done with number 5, are there any more questions on number 5? Okay, let's bring it on down to number 7. See if you can do VA and both of the intercepts without me, and then we'll bring it together to talk about that horizontal slant asymptote. Okay. So this becomes see one more time. How do you know if it's one? Nothing would cancel out. But if it does cancel out their holes. And that's why I factored it before I did anything, just to see if I could cancel anything out. All right, I've got my VA up there. I've got my x-intercepts. I've got 2 today, and I've got 1 y-intercept. And then Sophia asked a good question. There are no holes because we cannot cancel any factors. Even after I factored everything out, there was nothing that I could cancel out, so no holes here. Hey, you remember how we do our slant asymptote? Yeah, what do? Synthetic division, good. And how do I know I have to do synthetic division? How do I know it's a slant asymptote here? My exponents are different. The one on top is bigger than the one on bottom. So I'm gonna go over here, do my synthetic division. I've got -2 goes inside my house, and then my coefficients are 1, 2, and -3.
So you just do it, the top part, divided by the opposite of it. Okay.
Yeah, very good. Now that I divided it out, what is my polynomial or what's my binomial gonna be after this? It was x squared when we had the problem, so we have to go down an exponent, right? So it's gonna be x, y equals x. And then do I care about the remainder? Nope. I just have no y-intercept, or my y-intercept's just 0. I have nothing. I'm being added or subtracted. So we're gonna go graph that. We're gonna go graph y equals x, which is just that like linear function. It's just our basic linear function. I don't remember what this graph looks like, so I'll just look at it later. My asymptote's at -2. And my horizontal asymptote is at y equals x. So I go through 0, 0, 1, 1, 2, 2, 3, 3. We'll just dash line through there. Before I do anything else, oh, sorry, say that one more time.
right?
The slant line is that y equals x. So you're going to my y-intercept of 0, and then your slope is just up 1 over 1, up 1 over 1, up 1 over 1.
Wait, so the HA.
The HA is y equals x.
Okay.
Once you have your asymptotes graphed, let's go graph our x-intercepts at -3, 1, 2, 3, and at 1. And my y-intercepts at -3/2, so just somewhere between that -1 and -2.
Wait, that's why is the HA going like that?
Remember that it's a slant asymptote because my exponent is bigger on top than it is on bottom.
Okay,
And so that's why we did our synthetic division. And that's another hit. If you do synthetic division, it's not going to be a straight horizontal line. It's going to be some kind of like slanted line through your graph anyway. And now that I have these points, I just want to connect the points and then I just want to approach my asymptotes. So as long as I'm getting closer and closer to my asymptotes, it's less of a C curve. These are kind of almost flat, but they still are approaching your asymptotes and going through the intercepts that we have marked. Okay. All right, that is all. Your 2.6 homework, I think, has 2 graphs like this. 2.7 is pretty simple, so we're gonna just do those first 4 problems. They're just solving equations. I do think, unlike other chapters, this like section 2.6 is very much its own thing. Section 2.7 is very much its own thing. Section 2.8 is very much its own thing. So there's not a lot of continuity between them. Okay. Anybody questions on graphing before I move on? Okay. All right. So when we get into this 2.7, I swear we did this already. Sometimes I feel like crazy in pre-cal because we do that like pre-unit, like the chapter P. Do you remember doing that? And we just did a bunch of random stuff. We then like do it all again later. So like we have already learned this, but we're learning it again. Basically, your directions here are I want you to clear the denominator. So I do not want any fraction. Clear the denominator. I want you to solve for x. And then I want you to look for, or check is probably the better word, check for extraneous solutions. I don't know if we've talked about extraneous solutions, but is that a word you heard in either with me or with Algebra 2? Can you tell me what that means, anyone? You might be like, no, I know what that word is, I just couldn't tell you what it means. Anyone think that they have a definition? Yeah, solutions that don't work. So we're gonna solve it out and we may get a number that equals x, but then if we go to plug it back in, it doesn't actually work. So we will see that as we go, okay? So we're gonna do these first ones. What I think is the easiest thing to do is just take whatever is in the denominator and multiply it by everything, okay? So I'm gonna multiply everything by x. So x times x is x squared. X times 3 over x, the x's cancel, so I just get 3. X cancels, I'm just left with 3. And then do not forget to take it across the equal sign. We have to do 4 times x, which is 4x. Okay. Now that we get this looks like problems that we've solved before, right? Let's move everything to one side so we can decide, do we want to factor or do we want a quadratic formula? But I'll minus that 4x from both sides. And I get x squared minus 4x plus 3 equals 0. If you can factor, I would do that now. If you can't factor, then we quadratic formula. But I think we can factor this, right? What would this be if we factored it out? Amazing. X minus 3, x minus 1. So that means that x equals what? Good. 1 and 3, 3 and 1. Doesn't matter what order they go in. Okay. Now, when we check for extraneous solutions, that's when you need to go back. And all I really care about is that denominator. My denominator of x. If I plug 3 in, could 3 be a denominator? Would that be okay? Yeah. Could 1 be a denominator? Would that be okay? Good, what could I not plug in that would not be okay for a denominator?
Zero.
0, very good, Chase. So basically what we're looking for is if my answer is 0 or if my answer makes a denominator equal 0, that's when you have an extraneous solution, but none of these are extraneous. These all work totally fine. That's it. Can we do another one together? Good. What am I gonna multiply to everything on this one?
X plus 4.
X minus 4. I know that we've done conjugates before. There's no need to do a conjugate here. You want to multiply by exactly what you see in the bottom so that it exactly goes away. All right, so x minus 4 times x. I'm not going to FOIL that out yet. I'm just going to leave it as it is. X minus 4 times 1 over x minus 4 is just 1. And then x minus 4 times 0 is just 0. So that's easy. Now I'm going to distribute that x to everything. X squared minus 4x plus 1. If I had any like terms to combine, now would have been a good time. And then again, now I ask myself, can I factor this or do I have to quadratic formula? We got a quad form. So I'm going to label A, B, and C. And we're going to go ahead and do that. So x equals positive 4 plus or minus square root of negative 4 squared minus 4 times 1 times 1 all over 2 times 1. I'm going to start simplifying. X equals 4 plus or minus 16 minus 4 over 2. 4 plus or minus root 12 over 2. I like quadratic formulas. Sometimes it's annoying when you like have to keep simplifying because we can simplify root 12, right? So I get x equals 4 plus or minus, I think that's going to be 2 root 3 over 2. And then I can go one more step. I have 4, I have 2, I have 2, and they all have a factor of 2. So we can cancel that out. And I'm left with 2 plus or minus 1 root 3 all over 1. We don't need the 1 in the denominator, and we also don't really need that 1 in front of that root 3. 2 plus or minus root 3 is a good enough answer. Now, if I plug that into x minus 4, would that make my answer be 0? No, and I'm not even going to go plug it in because the only thing that would make this be 0 would be what? 4, right? So if it's not, if this answer isn't 4, I don't even need to go plug it in. I know it's fine. Let me start you on this next one and then you can finish it. Yesterday I was like, go ahead and do this one. And then someone was like, gave me like one of those weird eye looks. And I was like, okay, let's talk about it. Okay, when it looks kind of crazy like this, let's factor that last one. That's a big, long polynomial. Let's factor that down and see if that makes it easier, okay? If I factor x squared minus 4x plus 3, what does that become? X minus 3, x minus 1? Oh. That's the exact same thing as these over here, right? Now, let me show you two different things, okay? This is what I personally would do. Miss White, as a student, would just multiply everything by x minus 3, x minus 1, okay? And I would cancel out just like we have been doing, okay? So this is what it would look like. I would get 2x times x minus 3 plus, and then the x plus minus 3's would cancel, so I just get 1 times x minus 1, and then everything would cancel over on the last one, so it would just equal 2. Now, this is what I would do, then you can simplify it out. What I've seen a couple of you guys do, which is not wrong, is instead of doing that, and I'll zoom back out if you like that method, but some of you, and I don't know if you learned this in Algebra 2, you get these to have the same denominator and then you combine them together. So in this case, you would say, okay, in order to get this fraction to have the same denominator, I need to multiply by, let me get a different color, by x minus 3 on top and bottom here. So you would have one fraction that's 2x times x minus 3 all over x minus 1, x minus 3. And then the other fraction, you'd be like, okay, it already has an x minus 3, so I need to multiply by x minus 1 on top and bottom to get it to be the same. Does this look like anything that anyone naturally does? Okay. And then it equals the whole thing on the other side, 2 over that x minus 3, x minus 1. This is totally fine because now you have the same denominator for everything. So you can just cross that out. And do you see how that equals what I have already? That's the exact same thing that I wrote over here in pink. So you can do either way. However, it only was able to cancel because all 3 of these had the same denominator. You cannot just get these 2 to have the same denominator and then be like, oh, I canceled everything out. All 3 of them need the same denominator if you're going to cancel that bottom. Does that make sense? Either way, you get to the same place, so it doesn't truly matter. But I'm just letting you know that that is a different way that I've seen some of you guys do. But at the end of the day, we get down to something like this. So I'm going to keep simplifying. I get 2x squared minus 6x plus x minus 1 equals 2. I'm going to combine that negative 6x and plus x and get negative 5x. And I'm going to minus that 2 from both sides and get negative 3. Now this problem, you can always quadratic formula. However, I do believe this is a pretty easy factoring problem, so I'm going to factor it down. If this is a hard factor for you, that's fine. Then you have to use quadratic formula and you should still get the same answer as me. I'm going to get 2x and x. And I want to get, maybe we'll put 3 here and 1 there. So that's 1x and that's 6x. And I want it to be a negative 5. So we'll go minus plus. Yeah. And then once you have that, set each of them equal to 0. So we can actually solve for what x is. We'll say 2x plus 1 equals 0. So x is going to equal negative 1/2. And then x minus 3 equals 0. X equals 3. Now, before we move on to the last problem that I want to do today, we have to ask ourselves, are either of these extraneous solutions? Which one? 3, very good. If I were to plug 3 into that problem right there, that would give me a 0 in a denominator, and that is not okay. So I'm actually going to cross that out, and I'm going to write extraneous solution. And really the only answer is that negative 1/2. I like to still show that I knew that 3 worked and I knew that it's an extraneous solution. So I generally leave my answer like this, where I'm like, I know this is what x is, but I also want you to know that I know that I tried this and it's an extraneous solution. Does that make sense? So I label kind of both of them. If they both work, nothing matters. I just leave it in the little box, in the little circle. If one of them's an extraneous solution, I still list it as an extraneous solution. Okay, we got one more. Do you think you can try that one on your own? Nope, leave it as it is. Try and factor that first one down, or that third part down. Make sure you watch your signs. I just messed something up a second ago because I did a minus instead of a plus. And I'm going to combine like terms. Oh, those cancel. Oh, those cancel. I have mine solved. Once you have yours solved, we'll talk if there's any extraneous solutions or not. Anybody have any questions on how I've solved so far? Do I have any extraneous solutions?
Yeah.
Which one? Both of them. Oh. What happens if both of them are extraneous solutions? I would say that, yep, there's no solution. No real answer, no solution. Yeah.
I did it the other way. Whatever. And it's here in front of me.
Okay, when you look at this, like, it's supposed to get the axes together and then it's gonna bring, you got to boil it out.
See how I have it. See how I have it up here where I have it foiled out and I did X times X, so I did 2 times X, so I did -3. Yeah, you missed a middle term. All right, I'm gonna stop this video though.